So a lift goes up within a high-rise building so that its velocity is given by the graph shown below. The maximum velocity of lift during its ascent is 1.2. We can see that on the graph here. For the first 4 seconds, the acceleration is given by a is equal to kt, and for the final 4 seconds, it decelerates at the same rate. So we want to show the value of the constant k is 3 over 20. So we know that a is equal to kt, and that would mean that v is kt squared over 2 plus a constant. Now we can see that v is equal to 0 when t is equal to 0, just here. That means that c is equal to 0. So v is going to be kt squared over 2. But we also know that v is equal to 1.2 when t equals 4. So we get 1.2 is equal to c squared, 4 squared is 16, divided by 2 is 8, is 8k. And therefore k is going to be 1.2 divided by 8, which is 12 divided by 80, which is 3 divided by 20. So, using the incremental formula, determine the approximate change in velocity from t equals 2 to t equals 1 second, t equals 2 to 2.1. So what we're going to have here is the delta v is going to be approximately dv dt times delta t. So we know that dv dt is just the acceleration, which we know is 3 over 20 times t, and then we're going to multiply that by delta t. Well, in this particular case, t is equal to 2, and delta t is 0.1. So that's going to be 6 over 20 times 1/10, which is 6 over 200, which is 3 over 100, or 0.03 meters per second. We now want to determine the total distance the lift travels upwards during its ascent, correct to the nearest 0.1 meters. So basically we want the area under this graph. Now I'm just going to answer the question up here so we can see what we're doing. So we've got a rectangle here, the width of which we can see is 12 and the height is 1.2. So 12 times 1.2 is going to be part of it, and then we need, well, we know this area and this area is the same, so we can just work out one of them and divide by 2. So that's going to be the integral from 0 to 4 of the velocity, which we worked out was, so it was kt squared over 2, wasn't it? So the velocity k was 3 over 20, so that's going to be 3 over 40 t squared. So 3 over 40 t squared dt. So we have the calculator. We don't need to do too much messing around with it ourselves. So we can just do the integral from 0 to 4 of 3 over 40 times x squared dx and that gives me 1.6. So 1.6, and I've just got to do the 12 times 1.2, which is 14.4, and we'll just add that to the 1.6, and that gives me 16 meters. Oh, hold on a second, nearly made a mistake there. We need 2 of those, so let's just add another 1.6 onto that answer. 17.6.